All right, let's get right into it. Today, we're tackling a massive piece of object-oriented programming, how you can and should master the data inside your classes. So, you've probably seen this before, right? On one hand, you can just make everything public. It's easy, it's open, anyone can access it. On the other hand, you have this idea of private property with really controlled access. This meme kind of gets to the heart of what we're talking about. So, why do we even bother with the classier approach? Why not just leave the front door open for everyone? Well, first, let's talk about that danger zone. Because making all your data public is basically creating the Wild West inside your own code. And trust me, it gets chaotic fast. I mean, think about it. When your data is public, any other part of the program can just waltz in and change its value. No warning, no permission. This is how you get those terrifying bugs that seem to come out of nowhere, and it makes your code incredibly brittle and a nightmare to maintain. So, what's the solution to all this chaos? It's a really beautiful, elegant principle called encapsulation. And the best way to think about it is that you're building a fortress around your data. So, what is encapsulation, really? Well, at its core, it's the process of bundling your data, your variables, and the functions that are meant to work with that data, and sealing them up together inside a single protected thing we call a class. And this visual is just perfect. Your class is that protective capsule. Tucked away safely inside are your private variables, completely shielded from the outside world. The only way in? Through those public methods, which act as the official controlled gateways. And this gets you a huge win, something we call data hiding. By encapsulating everything, we hide all the messy internal details. And most importantly, we protect the object's state from being messed up by some random piece of code. Suddenly, you're in control. Okay, so if all our data is locked up inside this fortress, how do we actually get to it when we need it? Right, let's meet the official gatekeepers, getters and setters. Now, this is actually pretty simple. You've got getters, which are sometimes called accessors, and their job is just to read the value of a private variable. And then you have setters or mutators, whose job is to modify that value. It's read and write, but completely on our own terms. This quote just nails it. The key word, the absolute most important word here, is indirectly. We're not trying to make the data impossible to touch. We're just making sure that whenever someone does touch it, they go through the proper channels that we've defined. A bank account is the perfect real-world example here. Your PIN number? That's private. You would never, ever make that public for the world to see and change. But you absolutely need safe methods like a getBalance function. That's a getter. Or a deposit function, that's kind of like a setter, to interact with your account. So why even bother with a setter? Why not just make the variable public? The superpower here is data validation. A setter function can run checks before it actually changes the data. For instance, it can check if a course name is way too long. And if it is, it can just reject the change and print an arrow. It protects your data integrity. You just can't do that with a plain old public variable. Okay, so we know how to protect our data. But how do we make sure these objects are created properly in the first place? For that, let's bring in the automated construction crew. Constructors. A constructor is this special kind of function that gets called automatically the instant you create a new object. Its one job, its only job, is to build and initialize that object so it starts its life in a valid, predictable state. And they have a few quirky rules that make them unique. They have to have the exact same name as the class. They have no return type at all, not even void. They're always called for you, automatically. Oh, and if you forget to write one, the compiler is nice enough to just make a basic empty one for you. And even better, you can have what's called a parameterized constructor. This lets you pass in the starting values you want right when you create the object. It's like instead of getting a generic off-the-shelf rectangle, you can say, hey, build me one that's exactly 5 units high and 10 units wide from the get-go. All right, time to level up. Knowing what these tools are is one thing, but knowing how to use them wisely, well, that's what programming design is all about. And that brings us to a really critical design question, a trap a lot of us fall into. Now that you know about getters and setters, should you just automatically add one of each for every single private variable you make? What if I told you that mindlessly slapping a getter and a setter on everything kinda defeats the purpose of making it private in the first place? Yeah, you're not fully back in the Wild West, but you're only a tiny step away. You're still exposing all your internal plumbing. So here's a much smarter way to think. You have to be intentional. Ask yourself, what's this data for? If it's just for internal calculations, it doesn't need a getter or setter. If you want people to read it but not change it, just give it a getter. If two variables have to be changed together to stay consistent, use a single method to set both at once. And sometimes a specific action, like increment, makes way more sense than a generic set. You only add both a getter and a setter when you truly need that full read-write access.
This quote just hits the nail on the head. Encapsulation isn't about stopping change from happening. It's about defining a clear, reasonable, and well-thought-out policy for how and when that change is allowed to happen.
And this idea of a well-defined policy applies to an object's entire existence. See, objects have a full life cycle. They don't just pop into existence. They are constructed in a very specific order, and later on, they are destroyed in the exact reverse order.
Just look at this flow. A global object gets created first, before anything else. Then main starts and object 2 is born. Then we call a function, and in that function, object 3 and then object 4 are created. But as soon as that function ends, they get destroyed in reverse order. 4 goes first, then 3, then main finishes, and 2 is destroyed. And the very last thing to go, right before the program shuts down, is that global object. It's a perfect last-in, first-out system.
So we've gone from the chaos of the Wild West all the way to building these secure fortresses with controlled access and predictable life cycles. The big takeaway is to be intentional with your design. So the question I'll leave you with is, how are you going to design your next class fortress? Thanks for joining me.